Okay, in this class, in this time, we will analyze the promoter sequences that we extracted from laboratory. So we have putative promoter regions that is just calculated 500 bases ending at the starting of mRNA. So we were curated with regard to the strand information. So I think it is very relevant to the plant promoter database. Actually, this database is not that new. Actually, it is published at 2006 or 3, but I think they are keep updating the data very well. So I think this is a really good database. So I will explain you how to use this well curated data using Blast. Okay, so you can download actually this data. So 링크 주소 복사. I don't know how the English is showed to you, but you can copy the URL of this link and you open that Linux environment again and move to iPlant. Okay, now you can download this data in this way. Okay, 건집 -d plpr. This is plant promoter database. Okay, so they are calling it database, but it is collection of data. So it gives you a lot of Arabidopsis thaliana and Bigna radiata. Okay, and so the other information, actually I have no idea what that means. However, this is all promoter region that is experimentally curated. This is a really good data collection, right? So then how do you blast it? How do you blast it? So let me. Do I have okay. So you already have Conda. So let's go to sudo permission Conda install, right? Conda install. You can use Conda install and ncvr. Double check it. So Conda install blast. Then Anaconda Cloud, it already have blast. Okay, so Bioconda blast, you have to use Bioconda channel to install blast. It takes for a while. Is it recording very well or not? It's okay. So I have no idea why it takes. Oh, okay. It takes several minutes, but actually it installs properly. Almost done, right? So once it is done, it gives you make a blast db. Okay, so it gives you the command to make a blast db, so you can make blast db. db input is plpr, and the database type will be nucleotide. Okay, then it gives you these three different files. Actually, I believe these three different files is kind of index that BLAST can search against it. And now what do you need to have is that your query sequence in pasta format. So you have your data, your promoter sequences, promoter regions in this way. This is not actually pasta format. So I will write pasta file laboratory pasta promote pasta, right? Okay, and in writing manner is variable f. Okay, for index in mRNA, so the index will be not that good. So I will try. Did I make a definition for function info pass? Right. Okay. Function info pass. I want to make. I want to add function. No. Gene ID. Data. 8. Is it right? 8. Okay. Then apply lambda function info pass x was that's ID. Okay, that's I will say ID. Now what happened? The string index must be integer. What does that mean? Function info pass. Hold on. Function info parse x split. I need to change it a little bit. So I want to change this into just info pass. And Okay, then this data frame contains gene IDs, right? Okay, so gene ID. Each data frame X gene ID will be header print plus print 뭐였죠? promoter region promoter region will be file equal f. Again, what happened? Key error. Should be index. Okay. Once it is completed, then our directory will have promoter3 promoter pasta. Okay, it is done. Let's go to our directory. Okay, we have it. Let's check if it is well organized. Okay, so we have gene ID, but this is the promoter sequences. So everything is well parsed. Then how do you blast it? We will use blast n. Query. Our query will be this one. And our database. Our database will be this. And number alignment equal 1. I want to only one subject sequence, and e by u, as this is nucleotide, I will put it 1e minus 100. Okay, and our file server 3 pasta database name is this one. So, and e by u 1e back, okay, 100, and number of alignment is 1, and out. What? Too many positional argument. No, number of alignments. alignment. Let me calculate against our newly built database. This is coming from plant.prom in software database. So this is happening actually in your laptop, so this is amazing. It's already done. Then you can see many results. There is no hit. Oh my god, there is no hit at all. So what this actually means, promoter region is really evolve fast. It is not like coding sequence. So I will change the task. As blast n. I will see what happened. So default task is mega blast. So mega blast actually drive really similar sequences. But sometimes it misses a lot because the seed length is longer than blast n. If you are interested in the seed length, please search seed length. What the seed length means? It still doesn't have any result. Okay. Then I will change the E by U. The E by U will be just 10. If it does not give any result, then I will remove E by U. Then I will see it. I believe it actually usually the promoter region conserve just box, not all sequences. So usually it does not give proper cutoff of E by U. So maybe the result will be very similar, like this. Yes. No result at all. So I will remove the E by U constraint and see what happens. No. What does that mean? The invalid query sequence. I don't know why it produced this error message. Let me check what happened there. So when you have very small database, it is really good to have your database in your laptop because it is really fast to use it. So whenever you have so very small data means it usually be high quality data that you made. For example, in the database, it is sometimes not well curated, but your database that you manually curated data is really good for your project. So for your project, you have to keep your data in your laptop as a blast database. Then you can use it really in faster manner rather than using NCBI blast database. I don't know if it will give me actual result or not, but it takes a bit longer time than the learning with the E by U constraint. Sequence contains no data. Let me check. Let me check. So this is our data. Aha. So some data have a lot of n in there. This is why it gives us, oh my. This is the happening, what you use draft genome. So the draft genome means that, oh, in this case, it doesn't have any information. The draft genome is direct result from the assembly. So sometimes it is really good, but sometimes it is really not good. So not good means it has runs of n like this. Why they have n? Because first step of a de novo assembly is making config. Config doesn't usually do not have n stretch of n. Sometimes just one n or two n, but it config do not have this runs of n. But when you scaffold, so scaffold means the connecting two config into one. So when you connect the contigs into one, you have to use another evidence, for example, mate pair sequence. So your mate pair actually jump, for example, 5K or 40K. But when you jump one contig to another contig, but you cannot actually define the connecting sequences, so we just put a number of n's. So sometimes the number of n's can be calculated very well using certain statistics, but that statistics sometimes is not correct. So just runs of n means it use another evidence such as mate pair sequences. It does not contain exact sequences. So when you this is your starting point of your genes, but the upstream you don't have enough information to extract the promoter. This is why it gives us weird warnings. So okay, let's finish it. Let me check. Okay, so now it has certain. So I already told you that the E by U is sometimes not good. So it gives you boxes like this. So these boxes where conserve the boxes. So interesting, right? So this conserve the boxes is proteinase inhibitor and GMase. So this is the con, right? Con. This is conserved motif. You have. Okay. So many data box can be captured. Okay. Data box again. Data box. Okay. Yeah. Data box. Of course. Data box. Yes. Another non-data box stuff. Non-data box. Okay. So this is interesting because so this is Ora sativa, right? This is Ora sativa. So in total, how many? 13 sequences very well conserved across the genera. So monocode between monocode and dicode. This box is highly conserved, which means very important. This also, I don't know what this. This must be the neighborhood of the tomato. So this information can be used for your downstream analysis, but this format is not good for your analysis. So I will make output 7 using out FMT 7. So this actually gives you back not that alignment information, only gives you table information. So it can be parsed easily with pandas. Do we have enough time? I think yes. So I will do this lecture for another 10 minutes. Another 10 minutes. Then maybe I will maybe I can teach you how to parse this output into useful format. So actually, when you become familiar with the pandas, then this kind of table information is really helpful for you. When you do not understand the Python or pandas, then this table information is never necessary for you. But in this case, you already know how to use pandas, so it will be informative for you. I will remove this part. So what we've done is we tried promoter region. And we connect everything into one. Good. This is what we done today. Sorry. Oh, okay, now what we have. Let me check. Now we have output 7. So output 7 gives you this type of information. This type of information. So it do not gives you alignment. But you don't need alignment when you deal with pandas. Blast out. Yes, this way. Laboratory 7. Right? Okay. Separation. Step. Comment. Shop. Because you already showed it. Come on. It has a lot of comments. Right? So it has a lot of comments for comments. So I will exclude the comments. So telling them comments is shop. And header. They don't have a header. None. Okay, data frame blast out head. Then okay, we have proper table here, but it don't have a header. Of course, I explicitly tell them it doesn't have non header as with non parameter, but we can extract the header from file lover this way head 10. Okay, so this is so this one fields query and so on. This is all header information, so I will use it. Put this information in column. What was that? 3? Yes, 3. And split. I will replace this one and strip and split with comma, but still it has this empty blank, so I will strip it. Okay, cool. Column equal like this. Data frame last out column is C, right? Okay. Nice. To CSV. Number 3, this one, and profile, parsed CSV. Then you can open this file rather than the blast out file. Your life is better with this file. Okay. Now you have your query have target. Your query have target. So maybe I need to change the command because I put number of alignment to 1, but I don't think it is necessary in this case because your query can match it with many things. So I will run this blast again, but still I will work with this file and I will change later. Okay, so your query, this mRNA, the upstream of this mRNA have matching with this one, 100% identity. The alignment is 16 and 19 on 22. So if this is the I don't know if this is proper or not, but it looks kind of box, well conserved box. So kind list. List is 50. So the distribution of the number of boxes, the length of box is near this manner. So majority of box length is like this, maybe 22 or 30. Right? I put this into 100. Then you will see more clearly. Or you can use another module C1 as SB, and you can see KD plots. That's one. So this is the peak value of the alignment length. Right? So it looks almost 25. Of course, there is a way to label the peak here, but I will skip this at this time. label will be what? Length base t by label density. Okay, cool. Okay, then I think this is really convincing. Now we have promoter information. So let's extract the sequence. So query start and query end, subject start, subject end. So this is the BIOS, right? So this is the BIOS. So we can use data. So we have digfa for query. However, okay, this is not the one. So pasta to dictionary. Okay. So we need to have query pasta. So pasta to dictionary. So what was that? Laboratory promoter pasta was digpa query digpa subject pasta to dig PL. What was that? This one. These guys actually our query and subject. Flushed out. Okay, and our hit sequence of query core data frame blast out of line lambda x is equal 1 and x should, what was that, x query start x query end and dictionary pasta query x query this version. Oh yeah, this is complicated, but oh shoot, what is that? Key error, Q start. Why it give us back the error? It has blank. Lost out. Okay, so now we have a hit sequence query here, right? Now we have hit sequence query, and we can say we can change this one hit sequence subject. 그쵸? Hit sequence subject. Not query, subject. So subject exception version, subject and s and x. Okay. Okay. In this case, this is weird. I will check why it doesn't have any sequences here. Because it is reverse complementary. I don't think it gives reverse complementary. So This means that I have to write a function get subject sequence. This is whole this one goes to here. If the n is larger than this one, and return the sequence. Else the end start, right? Okay. I use here X. Let's see if we need to add reverse complementary or not. Okay, we have to, I think we have to put reverse complementary, right? So reverse complementary. Get level comp. Okay. Get level comp. I will change this sequence into uppercase. Okay, now we have sequences. So this is actually confusing bit. So I will extract essential information query accession version and the subject accession version. Maybe we need identity and alignment ranks, and we will use this one because I don't think it is the e value is necessary, because the e value is not the critical for this case. Okay, now we have this table. Rename the out curated. Okay, that's it. Okay, so this is how we retrieve the conserve the box in promoter region. So if you want to use the location of the promoter region, then you can use this Q start and Q. Maybe this is important. Okay. So query start and query, and you can paint your query sequence. So let me see. Okay, it is done. So I will change the file. Number of alignment. Then still it is similar with previous one, and I will change. Yeah. So it gives us 65,000 record for rubber tree promoter region, right? So we have enough information of promoter region. Let me see if we can retrieve more information from here. So this gives you the gene name, right? The product and gene. So let me use this information. So actually this is not, this is simple gene promoter info. Actually this is not Python, native Python grammar, but this allows you use command line command like this. So this is command line, Linux command line. So the result goes to this variable in list data format. Then now you have it for each in this information. So what is the time? So this is okay. Then I will explain this part next time. Okay. 수고 많으셨습니다. See you next time.